So today we are going to discuss the dielectrics. Most of the things about dielectrics you have studied in your school physics, but still let me tell you what are dielectrics. So these are substances which behave like insulators, but when these materials are placed in external electric field, then they they allow electric field lines to pass through them. So this is the definition of dielectrics. So they do not allow charge to pass through them. So they allow electric field lines to pass through them. So in case of conductors, what is the difference between conductor and a dielectric? So if you have a conductor, if you have an insulator, so and there in between we have a dielectric. So in case of perfect insulator, electric field cannot pass, electric current cannot pass. In case of conductor, you have electric current can pass, electric field lines can pass. But in case of dielectric, electric current cannot pass and electric field lines can pass. So therefore, it is some kind of intermediate stage. So it allows field lines to pass through it, but it does not allow electric current to pass through it. So it is in this manner, it is different from conductor as well as a perfect insulator. So we know that dielectrics are of two types. These are of two types. One are called polar dielectrics, other are called non-polar dielectrics. So in case of polar dielectrics, the net dipole moment of a molecule of molecule is non-zero. And in case of polar dielectric, sorry, in case of non-polar dielectric, the net dipole moment of molecule of the dielectric is zero. We know that dipole moment is the obtained when the center of positive and negative charge are away from each other. Only then you will get dipole moment. Now, in case of therefore polar dielectrics, in case of polar dielectrics, the center of positive charge and the center of negative charge these are separated from each other. But in case of non-polar dielectrics, the there is only one center of positive charge and same point act as center of negative charge. So due to that, we represent polar molecules with oval shape, and we can put one plus sign and one minus sign. And in physics, you know that the dipole moment is directed from negative to positive charge center. And representation of non-polar molecule is by a sphere, and you place one point. That same point is a source of center of positive charge, and that same point is a center of negative charge. Let me move to the next page. Okay, then let me take an example. Suppose we have nitrogen molecule.
एक्सक्यूज मी सर, एक बार
Yeah,
पिछला पेज खोलना.
yes. Yes, please ask. Should I move to next page now?
Excuse me, sir.
Yes.
Sir, please explain after non-polar dielectrics.
Yes.
After non-polar dielectrics, please explain again.
Non-polar dielectrics, the net dipole moment of these molecules is zero. How the dipole moment can be zero? We know from our school physics that dipole moment is the product of either charge and the separation between the charges. So if the separation between the center of positive and negative charge, you can write P, which is equal to dipole moment, is equal to Q into 2L. If you have 2L is equal to 0, what is 2L? 2L is this distance, the distance between two charges, that is the center of positive charge and negative charge. If 2L is 0, this will mean P is equal to 0, dipole moment is 0. So how the dipole moment can be 0? Answer is there is only one center for positive as well as negative charge. Same point act as center of positive charge and center of negative charge. Then dipole moment will be 0. But if the center of positive charge and negative charge are at different places, then the dipole moment cannot be 0. Is it clear?
Yes, sir. Thank you.
Okay, let me move to the next page. Okay, let us take the example of a nitrogen molecule. We know that in case of nitrogen molecule, the structure is like this. So the shade pair of electrons, it will be exactly attracted by both of the nitrogen molecules by equal amount, because affinity of both of these atoms is the same. So as a result, net dipole moment will be 0. As a result, net dipole moment will be 0. Gagandeep Singh can unmute himself and ask the question.
Excuse me, sir.
Yes, please.
Sir, when n have a lone pair, what is the dipole moment?
When
N has lone pair.
and every atom is non-polar. Every atom.
No, sir. If n has lone pairs.
No, he is talking of the lone pair on nitrogen atom.
Nitrogen has 7 electrons.
Yes, sir.
Yes. You are talking about nitrogen gas or atom?
Atom.
Atom.
Then I have given the statement every atom is non-polar. There is no atom which is polar.
Okay, thank you, sir.
There is no atom which is polar. Only molecules can be polar.
Okay.
Is it clear?
Yes, sir.
Any other question? Suppose we are having methane. Now it is a molecule. Now what is going to happen? The hydrogen atom loses these two electrons are shifted toward this. Is it okay? So the dipole moment of this will be toward this side. Sorry, hydrogen will be slightly positively charged. So this will be slightly positively charged. This will be slightly negatively charged. So dipole moment of this bond will be this side and this will be this side. Now both these bonds are polar, but the dipole moment of these two bonds is equal and opposite. So the dipole moment of right bond and left hand bond will cancel. Similarly, the dipole moment of upper bond and lower bond will cancel. As a result, methane, although it contains atoms of different kinds, but its dipole moment is again zero. Let us now discuss water. Now, this is water is the case where you have a lone pair also. You know this angle is 109 degree, I guess, 28 minutes. And again, electron activity of oxygen is very high as compared to that of hydrogen. So the shared pair of electron here at covalent bond is slightly attracted toward this oxygen. As a result, this gets slightly negatively charged, this gets slightly positively charged, this gets slightly positively charged. So the dipole moment is of this bond is like this, and dipole moment of this bond is like this. Now if we draw a parallelogram law of vectors, if you are having one vector like this, another vector is having like this, then there is an angle theta but within the two vectors p and p, where theta is 109 degree and 28 minutes. So what will be the resultant dipole? The answer according to parallelogram of law of vectors is that you complete the parallelogram, then the net dipole moment will start from this common point and it will be along the diagonal of the parallelogram. So this is the net dipole moment. Now which atom is placed here? The answer is H atom is placed here. And which atom is placed here? Again H. Which atom is placed here? It is O. Of course it has a lone pair of
एक्चुअली सर
yes please.
सर ऑक्सीजन ज्यादा इलेक्ट्रोनेगेटिव है तो सर डाइपोल मूवमेंट उसकी तरफ नहीं होगी.
बेटा केमिस्ट्री में जो आप डाइपोल मोमेंट की डायरेक्शन लिखते हो केमिस्ट्री में, इन केस ऑफ केमिस्ट्री सब्जेक्ट, we draw
Yes,
the
sir.
dipole moment from positive to negative, but in physics we draw the dipole moment from negative to positive. So
Okay, sir.
ये मैंने गलत कर दिया इधर.
हाँ जी.
Is it clear? Are you clear about this thing?
Yes, sir.
Yes, yes.
You noticed this thing in the plus 2 class also in your school physics.
Yes, sir.
So I, being a physics teacher, I will stick to the convention used by physicists.
और सर ऑक्सीजन पे दो लोन पेयर्स नहीं होते.
I do not know. I do not know. I do not have such a good knowledge about chemistry. If there are two lone pairs, then you have to show it like this, है ना?
Yes, sir.
Yes, sir.
But for me, this is immaterial. For me, the only information that the oxygen is more electronegative than hydrogen is sufficient for explaining this feature. I'm not going to discuss chemical aspects of water. Is it clear? Okay, what will be the center of this is the net dipole moment Pn, and you know that dipole moment starts from negative charge. So what is the center of negative charge? Answer is oxygen atom. What is the center
Oxygen.
of positive charge? Center of positive charge is this point. Let us say this point is S, and at this point S there is no atom. There is no atom. Please see it. You can appreciate it. There is no atom at S. So if I show if I show the polar structure of white water, if I show here it is minus and it is positive, and I call it that this is a water molecule, then the dipole moment of water molecule will be directed from center of negative charge to positive charge. Then kindly remember that at the center of negative charge there is what? Oxygen, but at the center of positive charge there is no atom. There is no atom. Hydrogens are actually, one hydrogen is to the right of positive charge, another hydrogen is to the left of positive charge. So this is what we mean as a center of charge. Just we say that a center of mass is the whole is the point where whole mass of the body is supposed to be concentrated. In the same way, we can say that center of charge is a point where whole charge of the body or molecule is supposed to be concentrated. So is it clear, students?
Yes,
Next,
sir.
next I will go to the part which is important for us, that is polarization of a dielectric. Polarization of non-polar dielectric. So what happens in case of non-polar dielectrics? If this is a sample, this is a material.
सर किधर गए?
भाग गए सर लाने डाइलेक्ट्रिक।
Disconnected.
जमगीड़ा बोला है।
कॉलेज का लाइट कट गया लग रहा है।
और कावलो की करा और अंकल सारे ठीक।
ओके।
और कावलो की करा।
हाँ यहाँ सब ठीक है, चल रहा है काम।
और इतनी ज़्यादा लड़की करा। मानो टेस्ट हो गई। कावलो कर दिया मैंने।
और बढ़िया है।
वो बंद कर ले नो। और सब बढ़िया हुआ। सर किधर गए हुए?
छुट्टी है, छुट्टी है।
कम करो एडी गाड़िया।
हाँ जी, हाँ करो करो। हाँ जी।
शहरों अद्दे बाढ़ दा
Students, can you hear me?
यस सर।
Yes, sir.
Okay,
Yes,
then
sir.
sorry, the battery of my laptop it exhausted. Now I have reconnected. So this is a non-polar dielectric. So you know that
Sir,
the
your screen is not visible.
okay, thank you. So I think everything has to be. Is it visible now?
यस सर।
Yes, sir.
सर
Yes, sir.
Sir, can you please show the previous page?
Okay. Yes. You want to ask something?
No, sir. Okay.
Okay, let me go to the next page. So what happens in case of a non-polar dielectric? The dipole moment of one atom is zero. What will be the dipole moment of the sample? Let us say PS stands for sample. It will also be zero, because if you multiply n times zero, the answer will be zero, because each dipole moment is zero. So the dipole moment of the whole sample is also zero. But what happens when we place a sorry this material in external electric field? Let us say there are negative charges here and there are positive charges here. Then the center of positive and negative charges are attracted in opposite directions. So each molecule which was non-polar, because of the attraction by the external electric field, which is directed from positive to negative, electric field is directed from positive to negative. So these molecules which were non-polar, these molecules will become polar, and as a result you will get negative charge accumulated on the surface of the material which is closer to the positive plate, and positive charge accumulated on the surface of the material which is close to the negative plate. And this process, after this process takes place, the dipole moment of the sample becomes non-zero, and this process is called polarization. You have some idea about this topic in your school physics also. So polarization is actually, we can define polarization as follows: when a dielectric material is placed in external electric field, then centers of positive charge of each molecule is attracted toward negative plate, and vice versa. Thus dipole moment of sample becomes non-zero, and bound charges are produced on the surface of non-polar sample. This process is called polarization. Kindly remember, these charges which are produced, these are bound charges. These charges cannot take part in conduction because these charges are still a part of the molecule. So this is the difference. In case of metals, the charges produced on the surface are free charges. These can move from one place to another. But in case of dielectrics, the charges produced at the surface are bound charges. These cannot move from one place to another place. If you have any question, you can ask. Otherwise, I will move to Ankit Kumar has already raised hand. Please ask your question. Unmute yourself. Ankit, I am not able to hear your sound. Two participants have raised hand. Kindly unmute yourself and ask the question.
Excuse me, sir.
Mm-hmm.
Can you please explain this diagram once again that you have drawn PS is equal to 0 and P is equal to 0?
Okay, please tell me. If I add 0 two times, what will be the answer?
0.
If I add 0 n times, what will be the answer?
0 only, sir.
Okay, very good. Now, these are actually molecules. These are non-polar molecules. So, the center of positive charge and center of negative charge will be same. Can you see
Same, yes,
this?
sir.
Okay. So,
Yes, sir.
what is the dipole moment at atomic level? Each individual atom. I have used
0 only.
it will be 0 only. If there are 1 lakh or 1 crore atoms in the sample, what will be the dipole moment of the sample then?
0. So the net dipole is also 0 because the individual dipoles of each molecule is 0, right, sir?
And that in the absence of external electric field. This is true
Okay.
in the absence of external electric field.
So the reason that you have created, the rectangle that you have created here is the region which has no external field.
Yeah. It is the sample. You have a cube of, let us say, wood, or let us say hardboard. Hardboard is a best dielectric to understand.
Yes, sir.
Okay, you have a cube of hardboard, and this cube of hardboard will be non-polar. Next,
Okay, so the individual molecules in it will be having 0
dipole moment.
dipole.
The dipole moment of individual molecule will be 0, and the dipole moment of the whole sample of hardboard will be 0. This is what the first figure signifies.
All right, sir.
And next,
Thank
this
you.
is the second figure. In this second figure, this is the same hardboard. Now I have placed it in between the plates of a capacitor.
Plates, yeah. Here we have external field, so it will be.
So because these are the molecules in which center of positive and negative charge at the same place. Is it okay? So what
Yes,
will
sir.
happen because of the electric field applied by the plates of capacitor? The center of positive and negative charges will go away from each other because these carry opposite charges. So negative charge will be attracted toward positive plate, positive charge will be
Positive.
attracted toward negative plate. As a
All
result,
right.
you will get a dipole moment of the material. So polarization is conversion of non-zero dipole moment into non-zero dipole
Dipole, some
by applying electric
non-dipole,
field.
0 moment.
Is it
All
okay?
right, sir.
Any
Yes,
other
sir. Thank
question?
you. No, sir.
So I will move to the next part. Hello, students. Now there is a how do we get polarization of polar dielectric? Now there is a question, very important question, which you should answer yourself. If you are unable to get it, you can call me. How do we get polarization of a polar dielectric? Please, some girl student asked a question just right now from me. Now she should better understand it. Now suppose I have a sample, and this sample, let us say it is a container filled glass with water. So in this, you will have various water molecules. I'm not showing the chemical structure of the water molecules. I'm showing their physical structure. Physical structure means I'm showing only the dipole moment. Please remember, at the tail of each arrow will be the center of positive charge, and at the head of each arrow will be the center of a negative charge. So please see, if I talk about atomic level, that same girl student, can please give me the answer to this. At atomic or molecular level, what will be the dipole moment of individual water molecule? Zero or non-zero?
0, sir.
No. Water is a polar molecule.
Oh, so sorry. It's water, right? So it will be non-zero. Sorry.
It will be non-zero. Now
Yes.
you see the difference. Let me show you the previous page. What was the dipole moment of one molecule here?
Here it was 0.
Sample.
Sample was 0 itself because all the
Because-
individual molecules were 0.
Now you can see the behavior at microscopic level and macroscopic level is the same. Whatever
Same.
is the behavior of same one atom, same is the behavior of all atoms.
Other one, all the atoms.
Atom word I'm using in appropriately. It should be molecule because
The
dipole
whole molecule.
Okay, let us come
Yes,
here.
sir.
Now look, what is the dipole moment of one molecule? It is non-zero. What will be the
Yes,
dipole
sir.
moment of the sample?
Here it should be non-zero again.
It should be
It may
zero.
be 0.
It usually is zero.
Say maybe, sir.
It may be zero. If it may be zero,
Or
if
not,
number
or not be 0.
please listen to me. It may be zero if the number of atoms or molecules in the sample are countable. But
Yes, sir.
the number of molecules are trillions, even trillions of trillions. So these are randomly oriented. And when these are randomly oriented, the net dipole moment of the sample is going to be zero. So we have made a conclusion whether the molecule.
I didn't get your point, sir. Can you please repeat again?
Look at this. These are randomly oriented. Why these are randomly oriented? Because all of these
Because
possess thermal kinetic energy.
Yes, sir.
And thermal kinetic energy is a source of entropy.
Entropy. Yes, sir.
And entropy is nothing but randomness.
Yes, sir.
And molecules are randomly oriented. Therefore, if you have one molecule having direction in this direction, then there must be one molecule having direction in exactly opposite direction. Of course, I did not draw it. Let me draw it. Because all directions are equally favored. If there is one water molecule whose dipole moment is from left to right, then in the sample there will
Cancel.
be another. Then these two will
Cancel out.
so as a result, because the number of molecules in the sample are billions and trillions, therefore the net dipole moment of the sample will be zero. So now you see in case of polar molecule, the behavior is different at microscopic and macroscopic level.
Okay, sir.
Know about the number of atoms.
Well, one pin of a needle contains billions atoms. I know that the radius of hydrogen atom is 10 raised to power minus 10 meter. That is approximately, of course,
No, sir.
it is 0.53. It is 0.53 angstrom. And diameter of hydrogen atom is 1 angstrom. Yes?
Sir, macroscopy level means 0 हो गया.
Yes?
Dipole moment.
Dipole moment at microscopic level of water molecule will not be zero.
Why?
Because at every molecule possesses dipole moment. There are certain students who are creating nuisance. I will mute all of you otherwise.
Sir.
Excuse me, sir. Sir, I was having a question that if we let that all the water molecules are having a one special direction, means they are not random, then the one who will touch that water will experience electric shock.
Yes, it can be. Why not? These things you feel when you come out of a car. Have not you ever got a shock from touching the walls of a car? That is called static electricity. It will be a one-time shock. It will be a one-time shock. Just simple, Sumal.
Sir.
Yes.
So net dipole moment of this water sample is 0 when it is only in the options of electric field, sir, right?
When it is only in the
options of electric field, right?
Outside the electric field. It is under the natural condition.
Options of electric field, sir, I am saying.
Absence or absence.
In the absence of electric field. Yes. You are correct. Now I am going to create polarization of this.
Excuse me, sir.
Yeah.
Sir, what if there are 5 molecules of water in this sample?
Then it will be. Then it can be non-zero. Because please look at this. If you have polygon law of vectors, you know this?
Yes, sir.
Yes, sir.
If you have a polygon of any number of vectors in such a way that the starting point of first vector and the end point of last vector are same, then what is the resultant of this polygon?
0.
0. Okay. If a
Yes,
closed
sir.
polygon is not formed,
Yes, sir.
then what will be the resultant of this open polygon?
Non-zero.
Non-zero.
Non-zero होगा sir.
This is where you should get answer by yourself.
This answer.
Smaller are the number of molecules in a sample, the smaller are the chances of closed polygons to be formed.
All right. And what if, sir, we have unequal number of molecules? Means we have the quantity is large, but the randomness isn't cancelled out every time. Like we have some odd number of molecules, and there is some direction net relatively. Then
Very good question. Fortunately, I know the answer to this question also. Actually, what happens then the things come like this. Let us say you are having one part which is this is one part which is non-zero. Is it okay? Then we
yes,
are
sir.
having 1,000 parts which are zero. What will be the relative importance of the non-zero part?
Negligible.
Is it okay?
Yes,
You are
sir. Yes, sir.
you are having a big sample. Let us big sample for me. Please remember, for me, even 1 centimeter cube is a big sample. Okay, because
All right.
a pin paper pin tip contains billions of atoms. So 1 centimeter cube billions or trillions atoms. So if I cancel it out, let us say the number of atoms in this sample of 1 centimeter cube are 10 raised to power 30, and let us say out of these there are 5 to 10 atoms which are not cancelling out. Then for me this is as good as zero dipole moment. It will be there. It will not be sensible. It will not be